Hey everybody, this is TJ Sutton with Avidyne's Tech Support Group, and this is the first in a series of videos we're going to do covering the SkyTrax 100B installation, and it's basically just to give you guys some training, a little bit of what to expect and some of the pitfalls to look out for. So in this first video we're going to be covering the introduction and the overview of the unit, just to get you guys kind of familiar with this new product. So there is the SkyTrax 100B. This is what the box looks like. You'll notice there is a TNC connection here. So this is going to be for your L-band antenna. There's a 37-pin D-sub connector. There's a micro SD slot. And what that micro SD slot is for future software updates and that kind of thing. Nothing you guys are going to need to do with that, at least right out of the gate. There's a USB Type-C connector here, and we're going to talk a little bit about that further down the video here, but that's where that's at. And this is going to be your configuration port. This is how you're going to configure this thing. You have a status light and some Ethernet lights, and we're going to get into some of that stuff throughout the video series as well. So first and foremost, SkyTrax 100B, what is this thing? Well, it's a 978 UAT receiver. It is not a 1090 receiver, and it does not provide ADS-B out. So the big takeaway from this is that we can still pick up the 1090 targets via the ADS-R. And what that is the rebroadcast. So the ground stations will take the 1090 targets, they'll roll them over on the 978 frequency and send them out. We can absolutely pick them up that way. The thing to be careful of there is understanding how your transponder or whatever your ADS-B out device is configured correctly. That there is a 978 receiver on board, but there is not a 1090 receiver on board. If you configure it for both, that tells the ground station not to bother sending ADS-R, and you'll miss out on all the 1090 targets because this is only a 978 receiver. Next we're going to talk about the power requirements here. As you guys can see, same unit goes into a 14 or 28 volt aircraft. So there's no difference in part numbers, but there is a difference in power requirement. As you can see, obviously it's going to draw about twice the current in a 14 volt aircraft as it does in a 28. So we'll want to do a little bit bigger breaker. So the STC requirement here is a 3 amp circuit breaker for a 14 volt system or a 2 amp circuit breaker for a 28 volt system. You can see the steady state current draw is nowhere close to that, but it does have a little bit of a power spike when you first boot the system up, when it first comes on. So that's where your 2 and 3 amp breakers come from. And as you can see here, 2 power pins, 2 ground pins, pretty standard installation, all coming from circuit breaker tied into the avionics bus. We also have interface ports on this thing. So there are 3 airing 429 ports. There's a port 1 transmit, there's a port 1 receive, and then there's a port 2 receive. So also important to understand, there's only one port that is a 429 transmit. So if you're going to be using 429 traffic out of this box, you're going to want to use that single port, and you're going to want to parallel that to multiple displays if you have multiple displays requiring airing 429. You shouldn't run into that scenario, and we'll get into those interfaces in some of the videos down the road, and we'll talk about the best way to wire these things up and get the most functionality out of the box. And there are 4 RS-232 ports, both receive and transmit for all 4 channels, and all 4 channels are completely independent. So you can set those 4 RS-232s up to different baud rates, different protocols, all of that. Which will come in handy when we get into some of the interface videos. It'll make a lot more sense. So the RS-232, we're going to use that mostly for the capstone protocols, for ADS-B traffic, FISB weather. This is the recommended way if you have a display that's capable of displaying full ADS-B symbology. We want to use RS-232 capstone protocols because that's going to give you the full ADS-B symbology. We can use the capstone protocols to do just the FISB weather, or we can use it for just the traffic, or we can use it for both. On the 429 side of the house, it's going to send out the old legacy task protocols. So it's going to look like legacy task targets if you use that airing 429. Some displays are only capable of that. So understand that you're not going to get full ADS-B symbology out of airing 429, and you are also not going to get FISB weather display out of airing 429. You'll need to use the RS-232 for the FISB weather. And we also have some inputs that are required. So for traffic display, we have to have GPS position coming into this box, and we have to have pressure altitude. So for GPS position, there's one of two ways we can go about it. We can use RS-232 utilizing either of the ADS-B Plus protocols out of our IFD series. This is what they're labeled as. It may very well work with a GTN or a GNS or something like that, but we haven't done any testing for it. It's not on our installation manual, so if you want to give it a shot, go for it, but we didn't do any engineering on that side of it. You can also use an airing 429 as long as it is 743A compliant GPS position. So this is what we're going to use in the R9 system, but again, we'll get into those details a little further down the road in the interface videos. Pressure altitude, we can bring that in via RS-232 in either Icarus format, Shaden RMS format, or the Shaden G, S, and Z formats. So we have some options there. If you have, let's say an Aspen EFD 1000, we can use that Shaden format from the Aspen for altitude. We can use Icarus format if you've got a serial encoder in the aircraft, or we can also bring it in via airing 429 as long as whatever that altitude source is providing label 203. Now, the big thing here that everybody should realize is that this thing does not have the capability to take gray code. So you're going to have to put an encoder in the aircraft if you don't have a PFD or some other place to source the altitude. Okay? Here are the part numbers and the parts that are included in the ship kit for the SkyTrax 100B. So you'll see you've got your SkyTrax 100B receiver itself. It includes a 37-pin D-sub female, 37-pin D-sub back shell, 37-pin D-sub slide latch to lock that guy on there, and some contacts. And that's pretty much it. So as you can see, you're going to have to source your L-band antenna elsewhere, and obviously the coax and the wiring, etc. A couple of things to consider and think about before you get started on the installation on this unit is if it's replacing one of the old SkyTrax MLB 100 boxes. You guys may remember some of those that we sold for a while that were rebranded Navworks units. The SkyTrax 100B will fit in the same footprint, and it is pin for pin compatible with that old MLB 100. So that's super handy because we're going to be using these to support those old units as well. The big thing to remember is that the configuration for this unit is done differently, so don't try to run the old MLB 100 UAT console on this. This is going to be a different animal, and we'll have a video that'll walk you guys through all of that, the ins and outs as far as configuring the SkyTrax 100B, because that's going to be different. The L-band antenna, I know some of these aircraft, it's getting pretty hard to find real estate, especially on the belly of the aircraft where we're going to place the antenna. Big thing to remember is that antenna needs to be located at least 2 feet from any transmitting antenna. It's L-band, it's 978 UAT, and it's pretty sensitive, so we don't want to damage anything by overdriving the signal on that antenna. So 2 feet from any transmitting antenna. And the configuration is going to be done by connecting up a computer to that USB-C type connection we talked about a second ago, and running a hyperterminal emulator. I mean, if you've got an old computer that has hyperterminal on it, and also has USB capability, maybe that's the way to go. There are several different versions of this out there, but for these instructional videos, we're going to use the program PuTTY. And the reason why is because it's free, it's readily available. If you guys don't have that on your computer that you're going to be using to configure this box, I would highly recommend you go out and get it. You can just go Google it, PuTTY. It's out there. You can download it. It's a free program. And it emulates hyperterminal, and that's what we're going to use in our instructional videos to show you guys how to do this. So I would highly recommend it. And here are the displays. These are the interfaces that the following videos in this series are going to be talking about. So compatible displays for the SkyTrax 100B, Avidyne IFD 500-400 series navigators, Avidyne Integra MFDs that have to be at 8.2 or later software, EX500, EX600 MFDs at 4.2 or later software, Avidyne R9 systems at 9.4 or later software, and the Aspen EFD 1000. Now these are the displays, these are the interfaces that are covered under our STC. I'm sure there are plenty of others out there that this box will work great with, but we haven't done the engineering. They're not in our installation manual. So you know, we'll probably have to do some research to make sure that there's some compatibility on those fronts. The ones we're going to cover throughout this video series are the ones that are covered in the install manual. And that's pretty much it for the introduction and overview of the SkyTrax 100B. Please continue watching, and hopefully you'll get some use out of these training videos. All right, thanks. Bye.